Today we're going to talk about Workbook 4A, Exercise 10. In the textbook, it's pages 23 through 26. There's a lot of words to say today because we're going to learn another new word to go with everything. You may have heard me use this word a few times. I've noticed as I say it, oops, I said the word that I haven't explained yet, but maybe that'll help you to learn the word already. The word for today is multiples. I've been calling multiples the count by numbers. So multiples of 3 are when you count by 3. The numbers 3, 6, 9, 12, and it doesn't stop there. 15, 18, 21, 24. We've been practicing counting by numbers, right? All of those count by numbers are multiples. So here's a couple of sentences to help you think about the words we've learned lately. 9 is a multiple of 3. It's a count by. If you count by threes, you land on 9. If you say that backwards, you would say 3 is a factor of 9. Remember, we just spent a couple of days talking about factors. You could look at another example and say 12 is a multiple of 3, because if I count by threes, I land on 12. 3, stated backwards, 3 is a factor of 12. So notice this information too. The number 12 has 6 factors. We've done this. 1 times 12, 2 times 6, 3 times 4. So there are exactly 6 factors of 12. 1, 2, 3, 4, 6, 12. But 12 has an infinite number of multiples. If I count by 12s, I never stop. I wrote them down up to 96, but I just keep going and going and going. So when you think of factors, know that there's a certain number of factors. You can list all of the factors. You can never list all of the multiples. So look on page 24. It asks some questions. Is 3 a factor of 36? And you could say to yourself, well, 36 divided by 3, I could do that. 3 tens divided by 3 is 1 10. 6 ones divided by 3 is 2 ones. So yes, 3 is a factor of 36. Is 36 a multiple of 3? Yes. If one number is a factor, if 3 is a factor of 36, then it's true that 36 is a multiple of 3. What about number 2? Is 3 a factor of 23? Well, if I think about those, 3 times 7 is 21. 3 times 8 is 24. If I do 23 divided by 3, I'm going to get a remainder. 23 divided by 3 is 7, remainder 2. So no, 3 is not a factor of 23. So no, 23 is not a multiple of 23. Look at question number 3. Is 12 a multiple of 2? In other words, if I count by 2s, do I get to 12? 2, 4, 6, 8, 10, 12. Yes, 2 is a multiple. I said it backwards. 12 is a multiple of 2. What about 3? If I count by 3s, do I get to 12? Yes. So 3 is a factor of 12, and 12 is a multiple of 3. What about if I count by 4s? 4, 8, 12. Yes. 12 is a multiple of 4. How about 5s? 5, 10, 15? Nope. That one doesn't work. 12 is not a multiple of 5. If I count by 5s, I do not land on 12. 6? Yes. Obviously 6 works. 12 is a multiple of 6 because if I count by 6s, I land on 12. Then another way to practice is to list the first 4 multiples of a number. If I count by 5, the first 4 numbers are 5, 10, 15, and 20. Notice the multiples of 5, it's 5 times 1, 5 multiplied by 2, 5 multiplied by 3, 5 multiplied by 4, right? The first multiple is when you multiply it by 1. The second multiple is when you multiply it by 2. So number 5, what are the first 4 multiples of 9? 1 times 9 is 9. The second multiple of 9 is 18. The third multiple of 9 is 27. The fourth multiple of 9 is 36. You can think of it as a pattern. 4, 8, 12, 16. The next 3 numbers in the pattern are the next 3 multiples of 4. In this case, 20, 24, 28. The next 3 numbers in the next pattern are the next 3 multiples of 6. 6, 12, 18, 24, 30, 36, 42. We're just counting by 4s, counting by 6, finding the multiples. Now on page 25 in your textbook, it gives a big chart and it does a great job of showing you something about the multiples of 2 and the multiples of 5. Look on that chart. Notice that it shows that the multiples of 2 are all circled. If you count by 2, 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, 24, 26, 28, 30, all of those are listed and they're circled. And then they took all the multiples of 5 and they put an X through it. Look in that chart and see what the answer to the question is. When a number is a multiple of 2, its ones digit is what? All of the numbers that are circled either have in the ones digit a 0 or a 2. What other number do they have in the ones digit? They also have a 4. Some of them have a 6. Some of them have 8. One of those numbers is always in the ones digit of a multiple of 2. When you have a multiple of 5, look at what you have. Either the ones digit is a 0 or a 5. That's always true. So these are just little patterns that we notice. We don't necessarily want to memorize the pattern. What we want to do is recognize that when you look at multiples and factors and things like that, there are patterns involved that are really helpful. So now number 8 is another really great pattern to notice. It says to write a number that's a multiple of 3. I wrote about 10 of them. It tells you to find the sum of the digits. Well, if you just have one digit, finding the sum is easy, but the sum is 3 and 6 and 9. 1 plus 2, that's the sum of the digits, that's 3. The next number is 15. The sum of the digits is 6. The sum of the digits of 18 is 9. The sum of the digits of 21 is 3. By any chance, are you noticing a pattern? The sum of the digits of any multiple of 3 is either 3 or 6 or 9. So I could ask you, is the number 355 a multiple of 3? And you could actually answer that question. 3 and 5 and 5 is equal to 13. That's not a multiple of 3 because that is not a multiple of 3 itself. The sum of the digits is not a multiple of 3. Notice, by the way, if I have 339, that is a multiple of 3 because I can divide it by 3 and get 113. And if I add those digits, 3 plus 3 plus 9 is equal to 15. So the pattern is not always 3, 6, and 9. The pattern is that the sum of the digits add to be another multiple of 3. So if the sum of the digits, that means if you add the digits up, and that sum is a multiple of 3, then the digit is a multiple of 3 as well, the original number. That's pretty cool, actually. And we'll practice that more as we go from here. That's always been true. We haven't talked about it before, but you can really look at count by 3 numbers and know if something is a multiple of 3 based on that. There's more practice to go for this one, so let's continue on page 26. We talked the other day about common factors. Now we're going to talk about common multiples. It's the same idea. If you look at the multiples of 4, the count by 4 numbers, 4, 8, 12, 16, 20, you've been practicing those for a long time now. Multiples of 6, 6, 12, 18, 24, all the multiples of 6. If you want to find the common multiples, you would find the ones that they have in common. So the first common multiple is 12. But then what you notice is 24 is a common multiple, 36 is a common multiple. I have every reason to suspect that 48 would be a common multiple, and sure enough, it is a common multiple. So there are more than one common multiples in any number, and notice when you find it, in this case it's 12, the next one is 24, the next one is 36, the next one is 48. What do you notice about those? Isn't that interesting? The common multiples of 4 and 6 are the multiples of 12. It's very interesting. All right, then number 10, just to make sure that we don't get confused by all the terminology, it wants to know of these numbers, which ones of these numbers are common factors of 36 and 63. In other words, if I do 36 divided by a number and 63 divided by a number, which ones work for both of them? If I divide both of them by 3, that works. If for no other reason, I know that because 3 plus 6 is 9, 6 plus 3 is 9, so that tells me that 3 is a factor of both of those numbers. What if I divide both by 4? Well, I know 4 goes into 36, that's 9, but 4 going into 63, that won't work because 63 is an even number, or is an odd number, and I can't take half of it and half of it again if it starts with an odd number. Or if you simply, 4 goes into 6 one time, 1 times 4 is 4, subtracting get 2. 4 does not go into 23 evenly, so it's not a factor of 63. So I'm going to mark 4 out. What about 6? Does 6 go into both evenly? Well, 6 times 6 is 36, so that's nice. But if I'm thinking about 6's, 6 times 10 is 60. If I add 6 to that, that would be 6 times 11, that's 66. 63 is not, or 6 is not a factor of 63. What about 9? Is 9 a common factor? Well, I know that 9 times 4 is 36. I know that 9 times 7 is 63. So 9 is a common factor. The last one I'm checking for this particular problem because it gave me an answer bank. It didn't say find all the common factors. It just asked if these were. 12 does go into 36, 12 times 3, but 12 does not go into 63. If I think in terms of 12, 12, 24, 36, 48, 60, 72, so 63 does not work. 12 is not a common factor. We have not done two-digit division, so that's why I went to just counting the factors, counting the multiples to see if 12 is a factor, right? If 12 is a factor, it's because 63 is a multiple of 12, and it's not. Part B of this goes the other direction. Which of the following are common multiples of 6 and 9? You could start that by thinking through common multiples: 6, 12, 18, 24, 30, 9, 18, 27, 36. The first common multiple is 18. Remember what we learned above? If 18 is a common multiple, 9 of course is not, the common multiples will be multiples of that number. So 18 and 18 is 36. Notice if I counted by 6 one more time, I would get to 36. So 27 is not a common multiple, but 36 is. If I add 18 again, I'm certainly not at 45. So of these numbers, only 18 and 36 are common multiples of 6 and 9. Number 11, find a common multiple of 3 and 5. 3, 6, 9, 12. Actually, the best way to find a common multiple is start with a larger number and count by 5s until you find one that you know to be a multiple of 3. 5, 10, 15. 15 is a common multiple. Now, one more thing I want you to see to help you remember things. You have a number. Factors are smaller than the number. Multiples are larger than the number. And anytime you're thinking about these words, make sure that you remember which one is which. Factors are smaller, multiples are larger, and that will be all you need to know to work on exercise 10.